Hello viewers, Wagda Ronald taking you through the story of O-Level Physics Paper 2. And this video, I'm going to go through the marking guide of Senior 3, beginning of Term 3 exam of Physics Paper 2. The question paper was already sent earlier, so I believe by now you have already tried it out, and now we are going to go through the marking guide so that you can mark yourself and check your progress. So these were the constants which could be used while attempting the paper. So we shall start with question 1. Part A says that state Newton's laws of motion. So the first law states that a body remains in its state of rest or continues to move with uniform velocity, know that word, uniform velocity, until it's compelled to act otherwise by an external force. So that word, external force, is needed. That was the first law. Now the second law states that the rate of change of momentum is directly proportional to the applied force that takes place in the direction of force. So this last word is very vital. Most students forget it. So that was the second law. What about the third law? Third law states that for every action there is an equal and opposite reaction. So that was part A. Now we shall go to B Roman 1. So B Roman 1 says that what is meant by linear momentum? So you come and say that linear momentum is the product of mass of a body and its velocity in a straight line. So when I put this word linear, you should remember to put this word straight line. So before we go to this slide, these are the marks for this slide. So M1, 1 mark for the first law, 1 mark for the second law, 1 mark for the third law, and here 1 mark for the definition. So this is 1 mark, not 3. So now shall go to part B Roman 1. So part B Roman 2. Roman 2 says that state the law of conservation of linear momentum. So the law of conservation of linear momentum states that when two bodies collide, total momentum before collision is equal to total momentum after collision, provided there is no external force applied. So this last condition is needed. So now shall go to part C Roman 1. Part C says a bullet of mass 20 grams, know that they are now using grams. A bullet of mass 20 grams is fired onto a block of wood of mass 400 grams lying on a smooth horizontal surface. If the bullet and the wood move together with a speed of 20 meters per second, calculate Roman 1 the speed with which the bullet hits the wood. So by conservation of momentum, we know that initial momentum before is equal to momentum after. Now before, if you look at this one, it was stationary. The wood was stationary. It was only this one which was moving. That is why you see here we have only M1U1. Otherwise we would have had M1U1 plus M2U2, but U2 is 0, so that's why there is only M1U1. Then here they move together with a common velocity, so that's why there is total mass multiplied by the common velocity. So you come and substitute. M1 is 20 grams, so you change to kilograms, which is 20 over 1000. U1 is what they want, M1 is 20 grams, M2 is 400 grams, everything divided by 1000 to change it to kilograms. Then V is 20. So when I simplify, I'll come up with this as 0.02 U1, and this one, the whole of this will be 8.4. Then make U1 the subject, U1 will be equal to 420 meters per second. So basically that's what they wanted for Roman 1. So 1 mark for stating the law of conservation of linear momentum. Then here 1 mark for stating the formula for conservation of momentum, and this 1 mark for this part, initial total momentum, and this 1 mark for the final total momentum. Then M1 for this 1 mark for equating the two, and this mark for making U1 the subject. So now we shall go to part C, Roman 2. So part C, Roman 2 says find the kinetic energy lost. So we shall first get the initial kinetic energy, which is that a half m u squared. So u was this. Then also get the final kinetic energy, which is that a half m v squared. So m is now total mass, which is that, and v was given, so you have to square it. So come up with 84 joules. Now when I subtract the 2, I'll be able to come up with the kinetic energy lost, which is 1680 joules. The units have to be seen. Now we shall go to part D. So part D says state the energy changes involved in C above. So kinetic energy of the fired bullet is converted to sound and heat energy on collision with the stationary wood, and kinetic energy of both the bullet and the wood after collision. So this half a mark for this substitution, half a mark for the output, half a mark for this substitution, half a mark for the output. Then full mark for subtraction, full mark for the final answer. Then you have a mark for this kinetic energy. Here when I say sound energy, that is half a mark. Heat energy, that is half a mark. Then kinetic energy for both, that is also half a mark. So this kinetic energy was for only the fired bullet, and this kinetic energy is for both the bullet and the wood. So that was question 1. Now we shall go to question 2. So question 2, part A says, what is meant by a light ray? So you come and say that a light ray is the direction of the path taken by light, as simple as that. So now we shall go to part B. Part B says that with the aid of a labeled diagram, describe the structure and working of a simple lens camera. So this, they said with the aid of a diagram, so let's first draw a diagram of a simple lens camera. So the diagram has to be labeled, so we shall start with this as the lens, then go to this as the aperture or stop, go to this as the focusing ring, go to this as the film spool, go to this as the film, that as the light proof box, and that is our shutter, and lastly this is our diaphragm. So that is a labeled lens camera. Now we shall go to description. First we shall say that light from the object is focused by the lens to form a real inverted image on the film. After that, we shall say that, so that was the film. What about the aperture? So the aperture controls the amount of light entering the camera, and the shutter controls the amount of light reaching the film. So we have this aperture which controls the amount of light entering the camera, and we have also the shutter, which is this, and it controls the amount of light reaching this film. So what happens to the film? So the image on the film is developed to give a negative. From the negative, the photograph is printed. So basically that is how a simple lens camera works. So now let's see how marks for this light can be obtained. So here for the 1 mark for the definition of light ray. Then for the whole of this diagram, we choose any four correct, and the diagram which is correctly drawn, that is 2 marks. Then for the description, that is where the 4 marks go. So 1 mark has to be for the real image, and 1 mark for the word inverted. So when I see this, that is full mark. When I see this, that is another full mark. Then half a mark for the function of the aperture, half a mark for the function of the shutter, half a mark for this word negative, and this word photograph, that is also another half a mark. So now we shall go to part C. So part C says that state 2 differences between the human eye and the lens camera. So one, we shall say that the lens of a camera has a fixed focal length, while that of a human eye has a variable focal length. Then 2 shall say that the lens camera has a variable distance between the lens and the film, while a human eye has a fixed distance between the lens and the retina. Then 3, we shall say that the lens camera focuses images by moving the lens relative to the film, while the human eye focuses images by changing the shape of the lens. The another one is that the exposure time for a lens camera is controlled by the shutter, while that of the human eye is continuous. Then next we shall say that the aperture of a lens camera is controlled by the diaphragm, while that of the human eye is controlled by the iris. Then next we shall say that the lens of a camera is artificial and rigid, while that of the human eye is a biological organ and is flexible. So any 2 of these differences, you get yourself the 2 marks. So now we shall go to part D Roman 1. So D Roman 1 says, state the laws of refraction. So 1, we shall say that the incident ray, refracted ray, and the normal at the point of incidence all lie on the same plane. So this word on is very vital. Then 2 shall say that for a given pair of optical media, the ratio of the sine of angle of incidence to sine of angle of refraction is a constant. So that was Roman 1. Now I shall go to Roman 2. So Roman 2 says, the figure aside shows a ray of light incident on a right angled prism. So this is not S, this is D. Right angled prism of refractive index 1.5. Explain why the ray of light follows up the path shown. Why here it is undeviated, while here it is totally internally reflected, and here it is also undeviated. So they want you to explain that. So you come and say that at P, the ray strikes the face of the prism normally. Normally means at 90 degrees, so it enters the prism undeviated. What about at Q? At Q, the angle of incidence is greater than the critical angle, so the ray is totally internally reflected. What about at R? At R still, the ray strikes the glass air interface normally. That means that it will be undeviated. So 1 mark for the first law, 1 mark for the second law of refraction. Here, when I see the word normally, that is 1 mark. When I see the word undeviated, that's another 1 mark. When I see the angle of incidence greater than the critical angle, that is 1 mark. When I see the word total internal refraction, that is another 1 mark. And this one is somewhat like a repetition of this, so that is 1 mark. So that was question 2. Now we shall go to question 3. Question 3a, Roman 1 says, define latent heat of fusion. So you come and say the latent heat of fusion is the heat gained by a substance in changing from solid to liquid at a constant temperature. So as long as you see the word latent heat, just know that temperature has to be constant. Alternatively, it is also the quantity of heat required to change the substance from solid to liquid at constant temperature. So what has changed is this word heat gained and heat required, but both are the same, both are correct. So now we shall go to Roman 2. Roman 2 says, describe with the aid of a labeled diagram an experiment to show the effect of pressure on the effect of increase in pressure on the melting point of ice. So the first thing to do that you have to draw a diagram, because they said to describe with the aid of a labeled diagram. So this is a block of ice. These are heavy weights, and this is the bare copper wire. So we shall see what each is used for in the next slide. So here you only write one definition, and here the diagram must be correct and all the labeling correct to get that 1 mark. So here I shall say that a block of ice is placed on wooden blocks, as we saw in the diagram. Then after that we shall say that a fine bare wire of copper with heavy weights attached at its end is placed across the block of ice to exert pressure on the block. So the heavy weights are to increase the pressure. Remember, we are dealing with effect of pressure on melting point of ice. So that was the procedure. What about the observation? The observation is that after some time, the wire cuts through the ice block without dividing it. So that is what you observe. Then after that, with that observation, what will be the conclusion? So the conclusion is that this shows that increasing pressure on ice lowers its melting point. So that was Roman 2. Now we shall go to Roman 3. Roman 3 says, if the melting point of lead is 327 degrees Celsius, find the amount of heat required to melt 200 grams, know this word grams, of lead initially at 27 degrees Celsius. Then they give you the constant. Specific capacity of lead is 140 joules per kilogram per Kelvin, and specific latent heat of fusion of lead is 2.7 exponent 5 joules per kilogram. So here it is easier if we first make a sketch of what has happened. So this was solid lead at 27, and this is solid lead at 327 degrees Celsius, and this is now molten lead. I think realize that there is no change in temperature, because as long as there is latent heat, temperature does not change, but the state changes from solid to liquid, and that is now latent heat of fusion. So with that sketch, we shall come and write that heat required is equal to, from here to here there is a change in temperature, so we shall use this formula. Then from here to here there is no change in temperature, so we shall use this formula. So M is mass, C is the specific capacity of lead. This one is the final temperature, and this was the initial temperature. M is mass, and this is the latent heat of fusion of lead. So we shall come and substitute, because we know all those ones. So we know the mass, but the mass was in grams, so we have to change to kilograms. This was that specific capacity of lead. Final temperature was 327, initial temperature was 27. Here mass is this in kilograms, and this was given as that. So when you simplify, the whole of this is this, and the whole of this is this. When I add the two, I'll come up with 62,400 joules as the required heat. So 1 mark for this procedure, 1 mark for the observation, 1 mark for the conclusion. Then here 1 mark for stating the formula, 1 mark for this part, 1 mark for this part, and 1 mark for the final answer. So now we shall go to part B, Roman 1. So part B says what is meant by the terms Roman 1 temperature and Roman 2 heat. So just that temperature is the measure of the degree of hotness or coldness of a substance. Alternatively, we can also define temperature as the number which expresses the degree of hotness or coldness of a body on a given scale. So any of the two, they are somewhat similar, so any of the two is okay. The next was the definition of heat. So we shall say that heat is the form of energy that is transferred from one place to another due to temperature differences between them. So now we shall go to part C. Part C says the fundamental interval of mercury in glass is 192 millimeters. Find the temperature in degrees Celsius when the mercury thread, this is not 3, it is thread, is 67.2 millimeters long. So you come and state the formula. So x is the length of the mercury thread, this is the fundamental interval, so you come and substitute. Mercury thread was this, fundamental interval was that, multiplied by 100 degrees Celsius. Therefore the temperature is 35 degrees Celsius. That was part C. Now shall go to part D. Part D says that state two physical properties which change with temperature. So 1 is volume of a gas, 2 is length of mercury column, 3 is resistance of a conductor, 4 is pressure of a gas. So n of the two, n of those ones. So here you choose one definition, that is 1 mark. Here I write this definition, 1 mark. Here formula, substitution, output, that is the 3 marks. Here you choose any two, you write only any two, and you'll be able to get your 2 marks. So that was question 3. Now we shall go to question 4. Question 4 part A says, what is meant by pressure? So I shall say that pressure is the force acting normally per square meter. So some students can say per unit area, though it is more better if you use the word square meter, because unit can be even 1 centimeter squared is a unit area. So it's better you use the word square meter, but also per unit area is also still okay for your level. So that was part A. Now shall go to part B, Roman 1. So part B, Roman 1 says, explain why one feels more pain when pricked by a needle than when pricked by a nail. So first of all, we need to know that for any given force, the pressure exerted on the surface is greater for a smaller area of contact than for a large area of contact. So this and should be than. Alright, after knowing that, we shall now come and say that a needle has a small area of contact compared to a nail. So what does that mean? It means that the pressure exerted by a needle is greater compared to that exerted by a nail. In that case, with a needle one feels more pain than with a nail. So that was Roman 1. Now we shall go to Roman 2. Roman 2 says that state the assumption made. So you shall come and say that it's assumed that the force applied is the same on both the needle and the nail. So that is how we could get the 1 mark for part A, 5 marks for part B, Roman 1, and 1 mark for part B, Roman 2. So now we shall go to part C. Part C says, with the aid of a label diagram, explain how a force pump works. So the first thing to do is to draw a diagram, because they said with the aid of a label diagram. So let's first draw the force pump. The next is to do the labeling. So labeling, we shall start with this being the piston, then this is the barrel, then that is valve B. We have two valves, so that is valve B, then this is valve A, then that is the air, this is the air chamber or reservoir, and this is the outlet or spout, and this is the atmospheric pressure. These arrows denote atmospheric pressure. So So your correct diagram with any fault correct labeling, that you get yourself the 2 marks. So now that you have drawn the diagram, now let's go to the theory part or the explanation part. So first of all, you need to know what a force pump does. So a force pump is used to raise water from a deep well or reservoir to a storage tank. So now let's start with the upward stroke. For the upward stroke, we shall see that when the piston moves upwards, a vacuum forms under the piston and atmospheric pressure forces water up through valve B to fill the space in the barrel. At the same time, this word is needed, at the same time, the weight of the water from the air chamber keeps valve A closed. So that was the upward stroke. What about the downward stroke? So we shall say that when the piston is pushed downwards, valve B closes and water is forced through valve A into the reservoir and also out of the spout. The air in the reservoir is compressed, and on the next upstroke it expands, so keeping the supply of water from the outlet constant. So now that was part C. Now we shall go to part D. Part D says that calculate the pressure exerted on the ground by a box of mass 10 kilograms when the corresponding area of contact is 2 meters squared. So we know that pressure is force over area. Now we are given the mass, so force is the same. The force will be carried for by the weight. So the weight is mg, so mass is 10 and g is a constant which is 10. Area was given as 2. So in the end we shall come up with 15 newtons per meter squared as our pressure. So remember, 2 marks for part C were got on the diagram, so 4 marks will be got from this theory, and this 1 mark for the formula, 1 mark for substitution, 1 mark for the final answer. So that was question 4. Now we shall go to question 5. Question 5 part A, Roman 1 says, define moment of a force, and Roman 2, state the principle of moments. So you come to the moment of a force is the product of a force and the perpendicular distance of its line of action from the point or a pivot. Then Roman 2, they wanted the principle of moment, so we shall come and say that the principle of moment states that when a body is in mechanical equilibrium, the sum of clockwise moments about a point is equal to the sum of anti-clockwise moment about the same point. So this word same point is needed. So that was part A. Now we shall go to part B. So that was part A. Now we shall go to part B. So part B says, describe an experiment to determine the mass of an object using a meter rule and a single known mass. So the first thing to do is to draw our setup, to illustrate our setup. that is our meter rule placed on a knife edge, and we shall show the forces of the weight, and also that one. So that's the diagram. We shall see what D1, what all these ones mean. So let's now go and now before we go to the explanation part, let's first see marks for this slide. So those are the marks for this slide. Now we shall go to the explanation part of the experiment. So we shall see that a uniform meter rule AB is balanced on a knife edge and the balance point noted. Then a known mass M0 is hung on one side of the meter rule at a known distance D0 from the knife edge. The object whose mass M is required is hung on the other side and its position adjusted until the meter rule is again balanced horizontally. The distance D of M from the knife edge is measured and noted. The required mass M is then calculated by taking moments about the pivot. So that means that when I take moments, I'll come up with weight as M0 G multiplied by D0 is equal to mg times D. And when I make M the subject, I'll come up with M0 D0 over D. So 1 mark for this balance point, 1 mark for M mass, non-mass, 1 mark for the distance, 1 mark for the required mass, half marks. So half a mark for balancing it again, half a mark for distance D, half a mark for this moment, half a mark for this moment, full mark for the required expression. So now shall go to part C. So part C says, this is the diagram and those are the forces. And here they say that forces of 20 newtons, 10 newtons and P act on a uniform rod pivoted at its center as shown in figure above. Find the magnitude of P if the system is in equilibrium. So taking moments about the pivot, shall come up with sum of clockwise moments equal to sum of anti-clockwise moments. So when you go to this diagram, with this as pivot, this force will give you a clockwise moment. What about this one? This one will give you anti-clockwise. What about this one? This one will give you clockwise moment. So clockwise moment there are two, there is 20 and there is 10. Then anti-clockwise there is only P. So for clockwise moment we shall say force times distance of 20 times 0.3, then 10 times 0.6, then the other will be equal to P times 0.1. So that is where this statement is coming from. So next is to use the calculator and make P the subject. So when I make P the subject, P will be equal to 120 newtons. So this half a mark for this moment, half a mark for this moment, half a mark for this moment, and this half a mark for equating the two. Then 1 mark, full mark for the value of P with the correct unit. So now shall go to part D Roman 1. So D Roman 1 says state 2 applications of the principle of moments. 1 will be action of a beam balance or weighing scale. Then 2, action of a seesaw. Then 3, action of a door handle. 4, action of a suspension bridge. 5, applied in loosening a nut using a spanner. Then also applied in removing a nail from wood using a crowbar. Then next is action of determination of center of gravity of a beam. Then used in determination of mass of the weight of a beam. Used in determination of relative density of a solid. So any 2 of these ones, you get yourself the 2 marks. Now shall go to Roman 2 of part D. Roman 2 says that draw a diagram to show the forces acting on an object resting on a table. So you first draw an object resting on a table, then when it rests on the table, the forces are 2, weight and normal reaction. So the weight acts vertically downwards and the normal reaction will act upwards in an opposite direction. So basically those are the 2 forces. That brings us to the end of this video. Thanks for watching, and be reminded that the next video will now be on topical tests. What you have been doing has been marking guides and for beginning of term exams for physics and math of O level and L level. So we have finished them. Now next is topical tests for both O level and L level. So if you have not yet subscribed, please click on the subscribe button below this video so that you receive updates when the next video for topical tests has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.